Okay. Okay. Welcome, everybody. This is the first session, no matter what uh, the screenshot says, of the Python course. In this lesson, we will cover the last element of the language, the thing that the only thing that we need to cover to have a full coverage of the syntax and semantic of the language, and that is classes. Okay, as you know, Python is also a object-oriented language, so here we will talk about how Python implements the object orientation. Surely you already have a little bit of experience. Maybe you have already created your classes, but uh, here we'll cover all you need to know about it. Okay, the structure of the class is that you see in screen. As you can see, the first thing is that Python allows multiple inheritance. So here you can have one or many parents, or you can have zero parents. If you don't have anything here, it understand that you are inheriting from the object class that is the base. But here is one of those places where Python 2 and Python 3 differs. If you are using Python 2, it's advisable that you always put the parent class, even if the parent class is object, because in the first version of Python, in the first version of Python 2, not all the elements were classes, not all the elements were object-oriented. And if you omit this part here, Python will use the old system. And in the old system, all the instances have the same type. Meanwhile, in the new system, when you explicitly include a parent here, every object has a type, the class where it belongs. I don't know if that's clear for you. The idea.
Basically, you're saying that all classes should derive from some other class.
Exactly. If you are using Python 2, if you are using Python 3, the old system doesn't apply. It's not necessary. Yeah. Okay. As you can see, classes also can have a docstring that it's used for documentation purposes as function, and also has methods have. You can declare attributes directly in the body of the class, and those attributes are class attributes. For example, this one that you see here, it's shared by all the instance. It's an attribute of the class and not of the object. If you change it, the change is reflected in all the objects. And the interesting part begins here. If you came from Java, for example, you know that the constructor has the same name of the class. In the case of Python, the constructor is called init. Well, underscore init, underscore. And the other thing interesting in Python, particular in Python, is that it doesn't have an implicit variable to refer to the current object. Instead of that, the first argument of a method makes reference to this object. And by convention, Python use the name of the variable self. So you must be careful there. If you came from Java, from JavaScript, from other languages, because in those languages you have a variable, a reserved keyword called this, that is accessible. You don't need to do anything. Instead, in Python, you must to declare the first argument and use it as the current object. And also, it's advisable that you always use the name self because it's a convention. If you put here this, everything will work fine. The only thing is that you will gain the hate of all Python programmers because we are used to use the variable self, right? Other than that, as you can see, the methods are the same thing, have the same structure as function. The only difference is that the first variable makes reference to the implicit object. And this is interesting because remember the philosophy of the language. In Python, things tend to be explicit. So the idea is that when you invoke the creation of an object, it's like this is just a general description. It's not completely exact, but it gives you an idea approximately. So when you invoke the creation of a class, what you are doing behind the scene is creating something like an empty dictionary, an empty object, and that empty object is passed as the first variable. So here inside init, you can make assignments to that object. And of course, that object has a reference to the class, and you can access to those methods, right?
Jose, so how do we destroy the objects? I mean, like once the objects job is done, then are they automatically like? I mean, they are removed from the memory, or is like you have to write specifically code to remove the object allocation from the memory?
Yes, and in Python has manage the memory for you. You don't have to worry about deleting the object or doing that kind of things. Once the object is not used anymore, it is eventually reclaimed from memory. There's only one small detail there, and it's that the memory management that Python uses is based of reference counting. So if, for example, you have an object A that contains object B, and object B contains or reference object A, both have, since both have one link to another, they will never be reclaimed from memory. Normally, this is not a problem because you have a tree-like structure when the reference go in one sense. But it's something that you must take in consideration if you have a more complex relationship between the object. There are ways to make weak reference to other objects, but it's simple, but it's not relevant for this introduction. Okay, so this is the structure of the class, as I told you. In Python, everything is an object, and every object can be seen, can be thought of as a dictionary. So when you declare a class, the class also is an object, and is also, you can think also as it as a dictionary. So here you are creating a dictionary of name my class. When you come to this point, you are creating an attribute inside that object. You are creating a method with this name inside this object, and so on and so on. And when you create an instance, you are creating an empty object. You are invoking this method and filling that object with whatever this method does to self. And of course, the semantic of the language make the chaining of when you invoke a method inside an object, if it's not an attribute of a direct attribute of that object, it looks in the class and go up. I told you all this because, well, you are programmers, you have an advanced knowledge of other languages, so this can help you to understand Python faster.
Jose, sorry to interrupt. Maybe you you mentioned this in the beginning, but I was not. So any class has to do a construction. So we cannot omit the init by default.
Yes, you can omit it.
Okay.
It's
okay.
not necessary.
If the constructor does nothing, we can omit. Okay.
Exactly, because as is common in all programming languages, every class is a subclass of another class, and if you don't declare an init method, Python nevertheless will invoke the init method when you create an instance. But if it doesn't find it here, it looks in all his parents, and eventually it'll get to object that it has defined an init method. So there's no problem there.
Okay, as I was just asking because you mentioned that the Python language is a explicit language, so that's why I was wondering. Okay, thanks.
Yeah. Okay. Okay. As I saw, so the attributes can be set either in a class or in an instance. Here is a class attribute. In an instant attribute would be self dot blah or dot foo equals to something. Yeah. Class attributes and instance attributes are accessible by all instances. Well, this is not exactly what I want to say here. Class attributes can be accessed by the instance too.
You mean the static ones, right?
Yes, we will talk about the difference between static and class. But let's omit this point that is incorrect. And that was also what I was telling you, that you can think about classes and instance as a dictionaries, because all the attributes of a class and all attributes of an object are stored in a dictionary. So at the end, when you say A.B, it's just a syntactic sugar to access to the dictionary of A and look for the keyword B And if you don't find it in the object, look in the class. And if you don't find it in the class, look in his parents. This is a little bit low level, but as I told you, I think that you are advanced enough to know this detail. If not, you can think that this is the common structure of how object-oriented languages work. Right. Okay, methods. Methods are functions that are defined inside a class. Python have three kinds of methods. The instance method are the normal ones. Its first parameter is an object. It's an instance of the class. And by convention is called self. These are the normal methods we are used to work with. The other is the class method. In the class method, the first parameter is not an object, it's not an instance, but it is the class itself. So this first parameter conventionally is called CLS, class. This is what I wanted to say here, only that I wrote erroneously. A class method only can access two class attributes. Why? Well, because it doesn't have any reference to an object. It only has a reference to a class. And that's a nice thing of having the explicitly the first argument indicating to what this method, to what this function have access to. And the third kind of method, the static methods, really are functions. They don't have any access to any instance or to any method of the class directly. Maybe you have found when you are programming a class that you need some utility method or you need some utility function. But in the case of Java, for example, you can write function isolated. You need to put a function inside a class. In Python, you can use function outside a class, but if the function is related with the class, sometimes makes sense to put it directly here. One example of one static method is, for example, the factory pattern. If you need to create an instance using an invocation to init that it's very complex, that requires to create several objects and pass it to as an argument, one option that you have is to have a static method that does that. For example, you can have a date class. The date class is used to represent the date of the calendar, and that date class can have a static method called today that returns a new instance of the date class with the date of today, that kind of thing. Finally, Python doesn't have abstract method as such, but you can define a normal method, an instant method that writes an error when it's called. That's the way Python indicates that we are in presence of an abstract method. So these are our 3-4 kind of methods. Now,
Jose, can you just repeat the last one, abstract method, what actually it does?
Yes, an abstract method is a method that is designed to be implemented by a subclass. So the basic class doesn't have an implementation, you can't create or you shouldn't try to create instance of a class with an abstract method. So the idea is that that method should return an error. Right? That's the idea. It's just an indicator that this method must be defined in a subclass, right? Okay. As I told you, Python accepts multiple inheritance. That means that you can inherit from more than one class. I won't go into the detail here, but in some language, how do you find an attribute of multiple inheritance hierarchy is that you look first left. So in some other language, what you do if you try to find an attribute of M is to look here, then to look here, then to look here. And if you don't find it, then you go back and do this, and then do this, and then you enter. You don't revisit a class more than once. But that method has its problem, and that's no Python does it. What Python does is to follow the diamond rule that basically what it does is that it tries to look first in the nearest ancestors, but it follows a topological order to try to avoid certain problems. For example, here, even if M inherits from A, B, and Z, since Z is a level below V, what Python does is that it first looks here, then look here, then look here, here, and here. Again, this is not something that you must worry about. You shouldn't be writing. You shouldn't be writing so complex class hierarchies. But it's something that it's important that you know that if you write this kind of complex hierarchies and something goes wrong, you must look to the order. And you can look at that order because that order it's accessible in an attribute of the class or using that method. It's only something to take in consideration. Okay, and the other important element is the reserved keyword or the built-in function super. When you want to access to attributes or methods of your parent class, you can do it in two ways. Since you know the name of the classes, you are a subclass, you can simply invoke those methods and pass self to those methods directly. Or you can use the built-in function super, and super will make this calculation for you and will look the attribute or will look in the super classes for you. So we will see this in some exercise in the practical session. Right? Okay. Now it comes our favorite part. I know that you guys like it a lot, the concept of decorators when we saw it last week. So here they come again. At the end of the last session, the last class, You asked me for some practical examples of decorators. In that moment, I answered with a decorator for functional methods to add or modify functionality. But in the Python language itself, they play a very important role, as you can see. We already saw a few slides ago that we have normal methods, instance method, class method, and static method. But we didn't see how to create it. Well, the idea is that we create them by decorators. Notice that if you don't put here this decorator, this is just a normal method. This name here is just a name. So for Python, this is exactly the same as using the self name. But when you put here this decorator, that indicates Python that this method should be or can only use with a class as its first implicit parameter, right? And the same thing for a static method. When you use a static method here, you are saying to Python, hey, when I invoke this method, don't pass an instant or don't pass a class as first argument. This is just a normal function. Are we clear here? This is the way on which we indicate Python that a method is a class method or an static method. Right?
Excuse me, Jose.
Yeah.
Does this method refer to class or instance?
I'm not sure that I understand the question.
Oh, usually, maybe not usual, but in PHP we have like static and dynamic methods. Methods dynamic refer to instances. And they may be changed. If we use static methods, these methods refer to classes, and so they can be used by any subclass, and it will call the same method as it is.
Yes, in Python, all methods are dynamics. That's why that was part of what I was trying to tell you when I was telling you here that a class is just an object, it's just a dictionary, and an instance is just an object, it's just a dictionary. When you have an instance, for example, you create the variable a, and a is an instance of my class, you can say a.blah. Since Python will try to find a method blah directly attached to an object, to the object A. And the normal case is that we don't put methods in the object, so it won't find it. Then it will try to find it inside the dictionary of my class, and he will find it there, and he will know that this method is static. So remember that a method is just a function, so in this case it's better to talk as it was a function. So he will find that this function is a static, so it will invoke it without passing anything special as first argument. When you invoke a normal method, when you say a.foo, Python find the foo function and pass as first argument a. Because, yeah?
May I? Sorry.
Yeah.
the argument in a static method, the first argument is the self instance,
the self
variable.
object. No, that's what I was trying to say. When you have an object A, if you invoke a normal method, if you say a.foo, if you create an instance of blah and you say a.foo, okay, what does Python do? It tries to find a foo name inside A. Well, inside A. It tries to find a foo method inside, directly inside A. And normally we don't put anything inside an instance. If it doesn't find it directly attached to the object, it tries to find it in the class. See? And it finds it. And look at this. Blackfoot, it's a method, but it's an unbound method. What does it mean? It means that it needs as a first argument an object of type blah. So you can invoke it in this way. But look at this. A.foo, Python make all those search behind curtains, and it finds that A doesn't has a foo, but its part is it's an instance of blah. Blah has a method foo, so it gets that method foo. But look that it returns a bound method. This method here, it's bound to the variable A. So I can say things like this. And now var is exactly the same that saying this here, it's exactly the same as saying this here, that it's exactly the same that saying this here. Normally, you don't have to worry about anything of this because you normally will use this. But it is interesting to know, and for advanced users, to know how things work behind curtains. And notice that I can say, for example, this. I added a method var to the object A, but I didn't modify the class. So that's why I tell you that in Python, objects are glorified dictionaries. You can do things to their, you can modify their interfaces, you can extend it, add methods, the same thing with the classes, and you have that power, right? So a static method is just a function that lives inside a class. You can access it through the object, you can access it through the class, but it's a function. It doesn't have any other connection. It can access any attribute of the object because we didn't pass self to it. You can access directly any property of the class because we didn't pass the class. So it's a function that lives inside a class. This instead is a function that has a direct reference to the class in the variable CLS, right? Okay. The other decorators that are related to classes are for getters and setters. In Python is not like Java when there's this culture of having private attributes and define a getter and a setter to access to them. So what's the idea here? The idea here, this is more used more for properties that are calculated. An example of this could be, for example, complex number. As you know, in complex number, a complex number has a real part and an imaginary part, or you can express the same number saying that it has a module and an angle. So you can define a property to give you the module of the number, and it will behave as it was an attribute, not a function. So you can access to it directly without calling a function, without using the parentheses. And also, you can assign an expression, a value, to a setter, and that setter can make something complex with that variable behind the scenes. Well, it's a function. It can make everything that a function does, but it gives you the beauty, the little syntactic sugar of not having to invoke the functions, but to use a direct assignment. And you also have the delete part. As you know, in Python, you can say things like this. And now, with this, you delete the property var from the object A. This is the same that invoking the letter function of the var attribute. So you can define these kind of things, right? Again, these are advanced use with almost everything that we've seen here. It's advanced because you already have experience with the object-oriented programs, and this slide here says everything you need to know for the basics of the class. Right? Okay. The other element that you have to take in consideration is name mangling. We already says that Python doesn't have private attributes. You can access to every object, every attribute inside an object. But Python offers something similar with the use of convention and a little bit of syntactic sugar. For example, the names that starts with an underscore, by convention, they are intended not to be used outside the class, not to be called by another object. They must be used only for the class, the superclass, this, etc. You also have attributes methods that start and end with a double underscore. We already have seen a lot of those methods, and those methods have a special meaning. Normally are related or are called behind the curtains when you use an operator. For example, underscore underscore add underscore underscore is used when you use the plus sign, the plus operator. When you use a getter or a setter to invoke certain methods. That's very nice because normally everything that the language does behind curtains has a method with double underscore associated to it that you can override and gain power over the language. But the third case on this scale is when you write an attribute that starts with two underscores but doesn't end with two underscores, Python does something behind the scenes. It does a name mangling. If you define a class and in that class you add an attribute that starts with two underscores, if we look inside that instance, notice that that instance doesn't have an attribute called underscore underscore a. Python rename it as underscore, the name of the class, and the name of the attribute. That's what name mangling means. And it's intended to give you a little more of privacy. Inside the class, you can access this attribute with this name. If you see this code and you try to access this attribute outside the class, you get an error because that name doesn't exist. Only inside the class you have access to that attribute. Okay. But of course, this is again just to give you a little more of privacy because you can always access to all the attributes in an object in one way or another. But you have to take this in consideration. Right. And okay, we talked about the special attributes in the previous lessons. We can see that we have when we have an object, we have access to a series of attributes. For example, the docstring of the function of the class, the class itself, the module inside which the class was defined. We have these two methods that are very nice, that converts an object into a string. This intended to be human readable, and this intends to be a string representation of the object as if it was Python code. We can even hack the way the attributes are invoked. For example, if Python doesn't find as you can see, you can see the variable foo doesn't have an attribute called car, for example. So if I try to access to this attribute, I get an error. But before I get this error, the Python tries to invoke this function here, and you can override this function and add dynamic attributes to an object. For example, this is very nice if you need to write a proxy to an object. So if the attribute doesn't exist in this object, you can try to get that attribute from the proxy object, for example. And this is the same. So, well, this is more low level. This is invoked even if the attribute exists. So you have all this control, and it's very nice for dynamic programming and meta programming, for example. And when you do things like this, you are invoking set attribute, and again, you can hack this process, capture this value, and make things like checking if the value is valid or not, that kind of things. So it's very hackable, all this process. Okay, that's all the relevant information about classes. Maybe if we have some time, we can talk about the only thing that remains to be covered. It's one special keyword, the keyword gel. It's the only thing that remains to be covered. And that has something to do with the concept of iterables and iterators, but I don't know if we have time for it. Maybe we should go to a break and return in 5 minutes.
Okay.
Yeah.
Okay. When you're ready, raise your hand. Are you ready?
Yeah, we're ready.
Yeah.
Okay, perfect. Okay, well, as usual, we will begin now with the fun part, the practical part. And as usual, we will start with a voluntary, with an exercise. The idea of the
I can
exercise,
go.
perfect. The idea of the exercise is, well, class and instance creation and the string and representation method. The problem is very simple. To create a class to represent a RGB color, so red, green, and blue color. So create a class that represent that color and create an instance of that object. After that, we'll add a little bit of functionality to that class. So, Eduardo, you will do it, right?
Yeah, I'll try.
Okay.
Okay, so let me
Share your screen.
exactly. What is this? Oh, yeah. Screen, this one, share. Okay, so class to represent something. Okay, so let's
Yes.
start with the class name.
Yeah,
Class
RGB color.
RGB colors. Okay, so RGB colors, for instance. Okay, so this class should derive it from the other class.
Yes, in general, since we are using Python 2, we will, if we don't have any base class, we will use object.
Okay, so that means
That class RGB colors object between parentheses. Very nice.
okay. So there is something wrong here. I put a comment here, but there is something wrong.
No, you need to put or you remove the parentheses in, or you put inside the parentheses the base class.
Which is? Ah, okay, object. Okay.
Exactly. Remember that if we are using Python 2, it's best to use object if we don't have a parent class. If we don't, we are using the old system where the type of an instance is instance instead of the type of an instance be RGB color, for example.
Mhm.
Okay, we need to okay, look, what you're doing there is creating a class variable, and we are not interested in to create a class variable. We are interested in working directly with instance. That is the common case. So you need to define the constructor.
Right. So yeah, okay, like this.
Exactly.
Okay. And now the constructor should have R, R, B, and R, G, B.
Exactly.
Okay, so now this, yep, two red, something like equals R. No, it's not like this. I'm not familiar yet with the syntax, but anyway, I will put
Yes,
it
yes,
here. But
I
anyway,
understand. Exactly. The idea it's you are very close, but that's the nice thing about Python is that it is explicit. As you can see, the first variable self represents the current object, and we
yeah,
want
okay, so self
exactly.
dot.
Exactly. How you wrote it, I think that it's done. I'm not sure if it's done in that way in Java. When if you don't use this, it's implicit. Okay, perfect. And the other thing is create an instance of that class and print it.
Create an instance of that class, and okay, so object okay, RGB object equals RGB colors. And I think I have to RGB object. I need to pass the values here.
Exactly. Normally the RGB colors are in or are real from 0 to 1 or are integers from 0 to 255. Exactly. And, and we need to print the object.
This is not quite print. There's something wrong here. RGB object.
Okay, since you are using Python 2, print doesn't require parentheses.
Doesn't require?
Parentheses.
Ah, yeah, okay, here.
It doesn't require, the print is not a function, but it's an instruction. And RGB is it's an object. You don't need the parentheses there.
Okay, so yeah, like this.
Okay, perfect. Let's run it.
Where is the mouse? I don't see the mouse. Okay, yeah.
Perfect. As you can see, it prints a representation of the object a little bit, well, it indicates the address where the object is stored. That we can do is that for classes are in camel case, so they start with caps. Perfect. Excellent. That exercise was just to illustrate how to create a class, how to create an instance, how to use the constructor. Now the following step is to begin to add methods to that class. The first method that we can add is a method to get the string representation of the object. That method is yes underscore underscore str str.
Say it again, please.
str yes underscore underscore str. No, str only.
Okay.
Underscore underscore.
Okay.
Exactly. Since it's an instant method, it takes self. It doesn't take any other argument, and it returns a string. The idea here is to return a string like we use in HTML, for example. Return a string that begins with a numeral and the hexadecimal representation of red, green, and blue. Yes, here I can help you a little bit. It would be only matter that look for the information in, for example, in format, or look for the information in the other operator, but I copied in the chat. How can you get that?
Where is this? Ah, here. Okay. Because I was starting to Google it.
Yeah.
Okay, with the okay. That is the this thing.
And execute the program again, please. Well, there's a little error, and it's that the object doesn't have an R, a G, or a B attribute.
Oh, yeah, I understand. It's red, green, and blue.
Okay, as we can see, when we print an object, Python try to convert that object into a string, and it looks for a couple of methods to do it. One of them is a string that it's intended to give a human representation of the object, and it's executed, and that's what it prints. The other method that we can create is the wrapper method, R-A-P-R.
The what? The writer?
Yes, exactly. Right now, R of exactly, A-P-R, exactly.
Okay.
Yeah, that method it's very similar to a string. It doesn't take any argument. It returns a string, and the string that it returns, it's the Python representation of the object. If you were to create an RGB color object, what string you have to type?
Sorry, the representation of the?
It's a string, and that string should look like the creation of an object in Python.
It's a dictionary, right?
No. Look at the line 20. When you create an object, you write RGB colors, open parentheses. Yeah. Yeah, the line 20.
Now you want me to invoke this method?
No. I want you to write in the line 70 an expression that returns a string, and that string should look like the second part of line 20. Like
With the arguments. Okay, so self. Okay, so this is a string.
it should look like where it's on the right side of the equal sign. So RGB colors,
Like this,
open
like
parentheses.
this.
Yeah, exactly.
Yeah, we have the return the self name, something like that.
Well, yes, but you already know the name.
Okay, so you want me hard code it?
Exactly, yes. Because,
Okay. So I was not. Okay, so let's. Well, that is easy. Yeah.
yeah.
And okay, so with the thing that we with the arguments that we are passing on to the class.
Exactly. Here you don't need to make any conversion.
So something like this. Wait. Oh. So this is what you want?
Yeah.
Oh. Okay, so let's do it.
Okay. The idea here is simply to illustrate that the use of the rep method that could be useful for you when you are programming, because you are going to need for debugging purposes to print the object, and it'll be nice to have this method in place.
But I don't understand. Why do I need ever to use this, actually? Isn't it can be done automatically?
What
do I waste my time?
That's why I was not understanding. Yeah.
No, of course you can use the debugger, for example, to look inside an object, but with Python you have this method that gives that it's intended to give you a textual representation of the string of the object. So
can you repeat what's the difference with wrapper and
string?
STR?
STR, it's intended for human consumption. So as you can see, in this case, we choose to use the HTML way of representing colors. Wrapper, it's intended to represent the color as if it was a Python code. So you should use the same name of the class, open parents, pass the arguments. So ideally, if you execute that string, you should get the original object.
So now,
No, execute the code. Okay.
Something is missing.
Yes. Well, you can use rep because that's the idea. Comment 1 second the struct method.
This
No, comment the one above that.
This one.
Yes.
The string. Okay. Code. Okay. Hmm. 21. Okay. What is the string? Yeah, you have to go. What is the? Yeah, and
Yes.
what is?
You should stringify it.
Yeah,
Cast,
yeah.
cast it to
Yeah, I
string.
understand, but how can I don't know.
STR and braces.
Okay. Yeah. Okay. Yeah.
That
Okay.
and a curious note that that function that you are using invokes the method str of red, of green, and blue.
Okay. So basically, shall I?
One more
Okay.
braces.
Okay. Yeah. I know. Wait. I was thinking about some other thing.
Yeah, you see, that's the idea. When you print an object, it looks for the string method. If it doesn't find, it looks for the representation method. The string method it's a string intended to be consumed by humans. The representation method is a string intended to represent Python code, to represent the constructor. I don't know what you're doing there.
No, I was trying something. Don't worry. I was playing around. Don't worry.
Also, the Python has as you can see, has the stir function. That what the stir function do, well, it's the same of calling. Yeah, of course, this give.
Yeah.
This is the same of saying this. And we have a method rep, and this is the same of saying this. Okay. Other interesting exercise could be to add a class method to return, for example, this is the way of we build colors normally, but we could be interested in get a color given a name. So that will be done with a static method, with a class method, for example.
No. Get color. Yeah. Now get color.
Name. Okay. Okay, but look that you are using a static method. You could do that, but in this case, maybe a class method it's better, because a static method is basically a function that has no relation with the class or with the instance.
I was just because you mentioned, so that's why I was decorated with a static.
Okay, but the decorator should for constructor it would be better to use a class method.
Okay, so
It's also a decorator, but instead of a static method, this class method.
Like this?
Yeah, and a class method his first parameter is the class, is CLS. Exactly. Okay, if the color name is red, return red.
Exactly. Well, so now it goes again the syntax. Well, now I don't know
Yeah.
if color name, is color name equals to sorry. So red, for instance. Can I use a switch case?
Semicolon, colon, what's the name? 2 point.
Here?
Exactly.
Okay, return self.
Okay. Look that you don't have self in.
Okay, so it's like this.
Okay, the idea is to create a new instance of the RGB colors, which represents a red.
Inside this method?
Yes, the idea is that.
You mean factory, right?
Exactly. We are
It's
get
just
color.
a factory by name.
Exactly. No, you have it right. The only thing you need to do is exactly choose what to return there.
Choose what to return here?
Yeah, and what you need to return is a new instance of RGB colors.
Yeah, but how can I represent this here?
Exactly. You can use.
Yeah, colors? No, it's not colors. It's the
Yeah.
RGB.
I think you need to specify braces here because you should create instance, so it's probably class and the braces and list of parameters, such as 255 and 2 zeros.
Exactly.
The way you initialize RGB colors, but you just place instead of RGB colors CLS word.
So you mean like this?
Yeah.
Yeah, and put
Okay, so
settings here.
Okay,
Yes.
thanks.
You could use a static method, and then instead of class or instead of CLS, you have to name the classes specific.
Okay, but now
Yes, you want to create an instance when red is 255 and green and blue are 0.
like this.
Exactly. And let's see if it works.
Yeah.
Create.
Yeah.
Okay,
no, but I need to.
Exactly. You need to use the method.
Yeah, exactly.
No, leave that part. Okay.
So get color. No. I have to use the method like this. Is that okay?
Okay, but let's go.
No.
First, okay, get color requires how many parameters?
Yeah, let me check. 1. Yeah.
Exactly.
So red. Yeah, I know. Wait. I was.
Yeah.
Wait.
Okay, let's see. Perfect. Now, look that you are invoking that method from an instance. That's perfectly valid because a class method, you can access to the class method from an instance or for the class. But normally, you would use directly the class.
Yes.
So
The class is okay. So in this case, I would wait. Instead of this, should be probably RGB colors dot.
exactly.
Like this.
Exactly. That's how you normally use a class method, but there are also cases when you can use it as you use in the 28 line. Also, a class method, of course, only has access to the class, so it can only access to class attributes or other class method. That's something interesting to consider.
Jose, a question for you.
Yeah.
Why is it that print method does not show string value magic method, but shows a representation?
Why print?
Print function, I expected that will return value that is specified in str, not in a wrapper. But now I see that it's wrapper, not str.
That's how it works. When you pass print an object, Python tries to convert that object into a string. The first thing that it tries to do is to invoke the str method. If it doesn't find it, it invokes the wrap method. Eduardo, if you scroll up your code, we'll see that the star method at this moment doesn't exist. It's commented. So if Eduardo uncomment that method, when you use print the color, it will use str.
Seems to me that is a source of problems. Because you will not be sure what you will get at the end.
But because we are using print object directly, we could use print str object or print wrapper object.
Yeah, but I mean that when you're saying that it should be stringified, it may be either because of problems that you forgot to initialize it, or it's not
yes, but
called in place where it should. But because you forgot to set attribute, for example.
No, because
it will work in any ways.
The idea of stringify an object is to give a representation, and we have two equally valid representations. The Python representation represents the object as it was Python code, or human consumable representation. In the case of color, we have the HTML color that is a very nice representation, and we can use that. So it's a matter of the semantics. Without the function, it's the human representation if there is one, or the Python representation if there is one. If there is none, then the name of the class and the address, the memory address. And underscore str, it's a method. The function of the reservoir is simply str.
Strange syntax.
Yeah, no, because the underscore methods are not intended to be used directly. Normally, You use it indirectly through one function, through one operator. Okay, but let's go to the following topic.
Yeah.
Yeah. A color has a property that it's called its luminance.
Luminance.
Yes, its luminance, it's calculated. I copied the formula in the chat. It's just a certain percentage of red plus certain percentage of green plus certain percentage of blue. So it represents how much brilliant the color is.
So it's a property.
Exactly. We can make a function, but since it's basically a value, it will be nice if we don't have to write color dot luminance open parents close parents. It will be nice if we simply write a color dot luminance. So how would you define?
Yeah, I need to look at how we define the properties.
Exactly.
I don't have the slide in front of me.
Exactly, but I can give you that. Here we are.
Yes, there must be some way to define it.
As you can see, it's just a decorator, the decorator property.
Yeah, exactly.
Over a method.
So wait. Okay, so property. So let's. We have to put something like this. Property.
We are not seeing your.
No, I was just okay. So I comment out this property. Define luminance, something like this, right? Luminance.
Exactly.
Okay, so property getter. So now, no, we have to define it.
Exactly. And a property, yes, it's a method that returns a value.
Well, I copied this, but
Notice that it doesn't need to be a string. In fact, we want that the luminance be a number.
yeah, this is the self. Self bring. Self move.
And we need, of course, to test it at the end by printing
it. Is this okay?
Yes, it looks okay.
Yeah.
We'll know once we.
Okay, so let's invoke it. This is the luminance property. So again, we have to print RGB dot luminance.
Okay, but
we
here you are saying prints the attribute luminance of the class RGB colors, and property, it's a property of an object. So you need an object to access the luminance property. In line 41, you declare you created already an object, so you have an object you can use to test.
RGB, I have this object. Oh no, yeah, the object. Yes, the object. You're yeah, okay, so luminance.
Okay, and the idea of a property is precisely not to use the parents to exactly have it as if it was an attribute. Perfect. Okay, we see in this exercise how to create classes, how to create instance, the string and represent method, class methods and properties. Exactly, we could use luminance exactly setter to set the value, but in this case it will be more mathematical than another thing, because you have to change red, green, and blue to keep the same proportion, but modify but that the new proportion gives you the luminance that you are setting. We are not going to this one. This is a setter, so in this case you don't return anything, but you modify the values of the object.
Let's see if the okay, so
yeah, but we
red value, green value, blue value, self red.
Exactly, but we are going to pass to another exercise, another voluntary.
Is it really possible to set 3 values at the same time, like now Dorda does?
Yes, you can do it.
Oh my god. So you have a getter which represents 1 value, but you set 3 values.
Yes,
it's kind of weird.
But makes sense, because imagine that you have all red. All red has a luminance of 255. If you set the luminance to 127, you are talking about half red. The same thing with white. If you have 255, 255, 255, you have a luminance of 1 of 255. If you want 10% of the luminance, you have to reduce the color of red, green, and blue in certain proportion. So in this case, it makes sense to do that.
I mean, well, my guess would be that luminance is single value, because in all editors you see single value as an input and as an output. What happens inside of it, it doesn't matter. But the idea, I would say, that should be that we change single value and we have some magic of mathematics which generates and updates multiple values.
Yes, exactly, that's the idea. If you change the luminance to half of the value, you want to reduce red, green, and blue in certain proportions, so you can keep the same proportion, but that the new values give you this luminance that you want. But of course, this is not exactly Python, but it's more mathematic than other things. So
how can I call this setter here?
You call it simply as it was an attribute. you would say object.luminance equals to value.
Okay, like, wait. Yeah, but I need, how can I pass 3? So,
No, but the idea,
luminance?
no, the idea is not to pass the colors. The idea is that the object will calculate the value of red, green, and blue.
That's why I was saying how can we set 3 values to single value?
Yes.
That was initial my question.
Okay. Well, I didn't understand. Sorry. Because the idea is that you see in luminance that every color certain percentage to luminance, right? If you have one color and you want to change its luminance, you must to keep the same ratio of red, green, and blue, but change its values. So I don't know if I explain myself. If you have 10 green, 20 blue, and 30 green, you have a luminance of X. If you want to have a luminance of 2X, you have to keep the same proportion of red, green, and blue originally, and that's how you can alter 3 values with one single value. You see? But again, this is not exactly a topic of Python. This is just a mathematical.
Okay.
Perfect. Then another voluntary for the next exercise.
Yeah, I can go.
Perfect.
Stop sharing.
The next exercise is to illustrate a method overriding and how to invoke methods of the superclass. So we will start with a simple class that represents a cat and with a method sound that prints meow. That's all we need to set up the problem.
Okay, sounds good. Let me show.
Too bad that Raluca doesn't. Yes.
Raluca approves.
Yes. We can give an attribute name just to make it interesting.
You were saying something?
Yes. To declare a function, you need def. Okay, but no, here things are more simple. We don't need to use attributes. Okay, please give it a constructor to this function so we can give the cat a name, for example.
Okay.
It's not a name, meow.
Exactly, perfect. And of course, we need a little bit of code to test it. Create an instance and invoke his method.
Okay, get.
Exactly.
Yeah?
We run it.
I can't do it. So confusing.
Just to make things a little bit more confusing. Okay, perfect. At this point, we haven't learned anything new. We already know how to create a class, how to create instance, how to define a constructor. The interesting part here is that we are going to create a subclass. That subclass will be happy cat, that will have an extra attribute, happy, that could be true or false. And the idea is to see how can we invoke the constructor and how can override the methods. Okay, look at this. When you write happy equal false in that way, you are creating a class attribute. So you are defining the happiness of all happy cats in one point.
No, but it's default value, just default value.
Okay. But we have another way to save the default
Cat
value.
by default is not happy.
Okay, if you want a default value, you can put it there exactly.
Oh,
Perfect. And here comes the question. How can invoke the okay, let's
like this?
very close.
Close enough? Or should I pass a self here?
Let's see. Let's execute and see the error message. No, let the first cat alone and create a new one. And
Okay.
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 And happy cat sounds. Okay. Exactly. Okay, as we see, we got an error, and the error is that super is not a variable, it's not an instant, it's a function. And it makes sense because a super it's intended to give you an object that represents the super classes of a class or of an instance. So you have to call super and pass the class that you're interested in get the super.
And how do I get parent?
That's a good thing. You always know what is the current class. The current class is happy cat.
Yeah, but should I? Okay, yeah, just put him. There is something like maybe self class name or.
You can use it. You can use the class attribute of the object if you don't know it. For example, if you are invoking the super inside an attribute passed to you. But in this case, since we're working in the constructor, we already know, and we know for sure. Okay, when you invoke super of a class, you'll get what it's called unbound methods. So you have to pass the attribute to those methods. The other possibility is that you can invoke happy cat, comma, self, and then you'll get a bound method. Though both possibilities are both are possibilities. You can use one of another. The difference, no, but that's all. There's no a third party.
So what does it return me? Super happy cat. So it will return the parent.
Yeah, it returns an object that will give you the super classes, so you can invoke the methods there.
Okay, so now we can invoke the constructor.
Exactly. Exactly. Let's try. Okay, let's do it the other way. Please comment line 15.
And what, 15?
Exactly, the line 15. No, the line 15. Okay, and we will use super only with the class.
What do you mean super with the class? Super?
Exactly.
And then what? What do you mean super only with the class?
Only in line 15 you use the class and the instance. Okay. Here you are only using the class. It's the same thing, exactly, but this time you need to pass self, because the init that is returning now doesn't know what is the instance, right? Let's try it.
We redefine this one or later?
Must be a type, not have a class. Okay, let's see the help. You are using Python 2?
Yeah, 2.7.
It should work. I don't know why. But let's go to the third way. Let's comment line 17 also.
Which line?
16.
Go with, yeah, because this one works.
No, comment 15 also. We are going to use another method again. In this case, this is the old method. This is the one that was used before super was introduced. It's not the best one because it's not dynamic, but in this case, we know what's the super class of happy cat, so we can invoke it directly. So how can we do that?
We just type cat.
Exactly.
Maybe we can.
And you need to pass self, because again, that's an unbound method. Okay, but the idea, okay, here we see how to invoke the superclass constructor using two methods. I have to review what it's finding this, the second one that we tried. Now we are going to see a method overriding and how to call super method. The idea of this exercise is to exactly to override sound, and if the cat is happy, it will purr, and if it's not happy, it will do whatever the superclass does.
Jose, a question for you.
Yeah.
What will happen if you will call this kind of init superclass you have now, when it's not your superclass?
I'm not.
You see, here you directly specify that you want to call init class for cat.
Yeah.
What will happen if it's not your superclass?
Well, that's a good question. I will venture that. Remember that what I always says that objects are just a dictionary. So if you use if you invoke any other constructor, I guess that it add the attributes that that constructor uses as it was a function. So basically,
so you basically can use any class and call it init, and it will create attributes for you and all things that is proper thing to do.
exactly, it will create the attributes.
Like JavaScript style.
Yes, it will create the attributes, but it won't have effects on the inheritance change.
Well, it will set values for self, correct?
Yes.
So if your inheritance will change and not cat but super cat, for example, will be expected to be a parent, then you will not see any problems until they happen in production.
But
But there is
the problems could be that if you don't invoke the super constructor, you probably won't get all the attributes. That's a real problem. But you won't affect the inheritance chain. If you invoke dog init, you still have a cat object with the cat methods and all that. The problem is that the dog constructor can maybe doesn't add all the attributes that a cat needs. But that kind of problem you have in other language. For example, in Java, you can, for example, well, I don't know if the compiler now protects from that, but you could omit the invocation of the super constructor, or you can use the wrong one, that kind of thing. Okay, okay, Alex, test it with the happy cat, and let's try with a sad cat. Perfect.
By the way, Jose, if you go to super, to the declaration, there are two parameters here. The second one is also required. So maybe there is some different in the versions. So to this option to work, it requires some older versions than I have.
Yes, it's probably. It's probable. Also, in Python 3, they did something very nice, that you can invoke super without any arguments, and it's context aware. So it knows if you are invoking it, it's an object that you're referring to the super of the current object.
Okay.
Well, that's all about classes, and it's all for this session. The next one will be not about the language, because everything is covered with the only exception of GELD and the iterators. We will go there with pragmatics, how to define modules, commands, package, how to handle the environment, that kind of thing. So, thank you guys, and see you next Tuesday.
Thank you.
Thank you, Jose.
Man.
Thank you.
Thanks.
Thank
Goodbye.
you.
Bye.